Hi, I'm Celia Marahata and I'll be presenting on cybersecurity in robotics and industrial automation. As robots become more connected and widely used in industries, cybersecurity has become a critical concern. In this presentation, I'll explain why cybersecurity matters, the type of the threats and risk involved, and how modern systems are designed to stay secure. Cybersecurity refers to protecting robots and control systems from hacking, misuse, and unauthorized access. The main goal is to make sure that robot operates safely, reliably, and exactly as intended, especially in critical environments like factories or healthcare systems. This applies to many types of systems, including industrial robot, autonomous vehicles, and IoT connected devices that are used all around the world. So let's look at why cybersecurity matters in robotics and automation. First, protecting critical systems and preventing downtime. Robotic systems are widely used in industries like manufacturing and energy. If a cyber attack happens, it can stop operations completely and cause major financial losses. A well-known example is the Stuxnet attack, which disrupted industrial equipment. Second, preventing physical damage and safety risk. Unlike regular computer systems, robots interact with physical world. If a robot is hacked, it can behave unpredictably, damage equipment, or even harm people. Third, securing IT and OT integration. Modern systems combine IT, which is software, with OT, which is physical machine. While this improves efficiency, it also increases vulnerability to cyber attack if not properly secured. Now let's talk about some common cyber threats that can affect robotic systems. Some of these might be new, so I'll briefly explain each one. First, malware attack. Malware is basically malicious software like viruses or ransomware that can affect a system. In robotics, this could disrupt operations or even take control of how a robot behaves. Next, unauthorized access. This happens when someone gains access to a system without permission, usually because of weak password or unsecured networks. Once inside, they can control or manipulate the robot. Another important one is supply chain attack. This is a bit different. Instead of attacking the system directly, hackers target a trusted third party, like a software update or vendor, and then use that to get into the system. So the system gets compromised through something it trusted. And finally, man in the middle attack. This happens when an attacker secretly intercepts communication between two systems. They can listen to the data being exchanged or even modify it without either side knowing. So, overall, these threats show that attacks can happen in different ways, either directly, indirectly, or through communication, which is why strong cybersecurity is very important. Now let's look at why these attacks are possible. The security risk. Weak passwords and poor authentication make it easy for attackers to access system. Unencrypted communication allows attackers to intercept or modify data being transmitted. Outdated software can often contain known vulnerabilities that can be exploited. Poor network security allows attackers to move across systems once they gain access. And finally, integrity and availability attacks can alter system behavior or overload systems, causing failure or disruption. One of the most important platform in robotics is ROS, the Robot Operating System. For now, we have two versions, ROS 1 and ROS 2. ROS 1 is the older version. It uses a centralized system and does not include built in security features. It also lacks access control and encryption, which makes it less secure. Whereas ROS 2 is designed for modern application, it is a newer version. It uses a distributed architecture based on DDS, which improves communication. It also includes security features like authentication, policy-based access control, and encryption using AES GCM. So overall, ROS 2 is much more suitable for real-world and secure robotic system. In industrial environment, machines communicate using protocol like Ethernet IP, Modbus, and OPC UA. These allow real-time data exchange between devices like sensors and controllers. However, many of these protocols were designed a long time ago, focusing on the functionality rather than security. This creates challenges such as lack of encryption, weak authentication, and poor network design, which can allow attackers to intercept data or access systems. So to address this, industries now use secure protocol like OPC UA, apply encryption method like TLX or VPNs, and use network segmentation to limit access. Securing communication is important to ensure safe operations, prevent unauthorized control, and reduce the risk of cyber attack. Now let's explore several cybersecurity techniques that are used to protect robotic systems. Encryption. Encryption helps protect data from being intercepted during transmission. Strong authentication ensures that only authorized user can access systems. Network security. Network security, including firewalls and segmentation, help isolate critical systems. And finally, regular updates are important to fix vulnerabilities and keep systems secure over time. So let's look at the real world example, the Stuxnet incident. Back in 2010, something unusual started happening at Iran's nuclear facility. The machines which were centrifuging the uranium were suddenly failing, but no one could figure out why. Everything on the monitor system looked completely normal. What they didn't know was that a hidden cyber weapon, Stuxnet, had secretly infected the system. It was designed to target industrials' control system and quietly change how the machine operated, making them spin at abnormal speeds uh, while spending while sending false data back to the engineers. So from the outside, everything looked fine, but in reality, the machines were slowly being destroyed. How this happened was the attack exploited unknown software vulnerabilities spread through infected USB devices, and once inside, it moved through the network because that there weren't strong segmentation. This incident taught the world an important lesson. Even highly secure system can be vulnerable. It showed the need for regular updates, strong network separation, monitoring for unusual behavior, and limiting external devices like USB. And most importantly, it proved that cyber attacks are not just digital, they can cause real physical damage in the real world. Alright, so to wrap everything up, let's quickly go over what we have learned today. We saw that cybersecurity in robotics is not just about protecting data, but also about protecting physical system and human safety. We learned that robotic system can face different types of threats like malware, unauthorized access, and communication attacks. These attacks become possible because of weakness such as weak password, unencrypted communication, outdated software, and poor network system. We also looked at how modern solutions like ROS2 and secure industrial protocols help improve security through encryption, authentication, and better system design. And finally, through the Stuxnet, example, we understood that cyber attack can cause real-world physical damage, which makes cybersecurity even more important in robotics and automation. So overall, the key lesson is that as robotics become more advanced and connected, strong cybersecurity practices are essential to ensure system remain safe, reliable, and secure. And with that, this was a short lesson on cybersecurity in robotics. Thank you all for listening.